Well, greetings, Mr. Kolazar's class. We're going to start looking into section 2.4 in your notes on accuracy and precision. And our first part about this is going to be just when we're making our measurements, what we're going to be looking into. So accuracy is going to refer to how close a measure is according to its accepted value. So what it's believed to be and how close we are to measuring out to be exact what it's supposed to be. Precision then refers to a different type of measurement idea, and it refers to how close the measurements are to one another. So how can you repeat, or how well can you repeat your measurements, is what precision refers to. So if you're throwing darts or an archery, somewhere like that, what could be doing as an analogy is to draw out each of these targets. We got kind of our bullseye area, and then you're trying to hit closest to the target. Our first one is accurate. So you're accurate if you can actually hit the center of the target. So an arrow in the center of the target indicates high accuracy. How close to the intended mark are you? Now our second attempt here kind of shows good grouping. All of them are here, 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 so they're all very close to one another. So when we're looking at this, your measurements are all close to one another. That would be precise, but they're not in the intended target area of where we should be, so it's not accurate. So arrows far away from the center indicate low accuracy, but if they're close together, that's high precision. So them just being close together, each of those measurements, and we'll talk about one of those examples later on when it comes to weighing. Accurate and precise, this is what we're trying to do. So that's what you're trying to do, where you're hitting the center of the target measurement-wise, and each one, you can do it multiple times or you can repeat your results. So arrows in the center of high accuracy, arrows close together, high precision. And then we got one arrow over here, one over here. We're all off the chart, all in different places. We're not accurate, we're not precise. So arrows, low accuracy, low precision would be what our measurements are there. Now to look at an example here, we're going to look at, say we're actually measuring something, and our intended target is to be at that 15 milliliters. Now, we have Joyce, Monty, Carbel, and Josephine are our three people here. And each of them are four people. And each of them made three measurements. I want you to change our measurement here to 14.0 milliliters. So just a slight little change that we're going to make as we're working there. And what we're looking at is how these compare to one another. So as we're comparing these, how does the 13 milliliters and the 17 milliliters and the 14 milliliters, those three measurements compare? Or in the next one, Monty's 15.03, 15.01, 14.99, Carbel's and Josephine's, how do they compare accuracy versus precision? So what we're going to look at is, I'll just jump back and forth because it's on mine slide-wise, accurate and precise data. So if we look back, whose data is close all around? And if we look and close to that intended target, so what you're trying to get to is whose data is accurate and precise. And as we're looking, Monty's 15.01, 15.03, 14.99, we're all very close to that 15.00 mark with those two extra decimals at the end. So we're going to start out, accurate and precise would be Monty. Accurate but not precise, so whose data might have actually hit the target as we're looking at each one of those. So if we go back through, Josephine, accurate but not precise data. So she had some that were right on, or one that was right on the mark, but the other two not quite. Not accurate but precise, so who is close each time, but not where we're supposed to be. And if we look at Carbel's, 15.0 or 12.50, 12.53, 12.49. All of them are very closely grouped together, but they're all just off by about 2.5 milliliters. So not accurate and not precise. Carbel, neither accurate nor precise. When we look at Joyce, she's kind of all over the map with those measurements of each of those. Now where this actually can fit in well, accuracy versus precision. When performing an experiment, you're striving for accuracy and precision. So how close you are to the intended mark, and from there, precision, how close are you at each of your measurements? So can you repeat these measurements time and time again? Precision, often limited by the tools available. So as we're looking here, the precision, the more decimals you can get will be a key part there. So, as you're looking, if you got a sample that's 1.32 grams or 1.3215 grams, the more accuracy you have, but eventually those decimals kind of just run out depending on how precise. It gets more expensive for those instrumentations also. One place we could actually see this, an example of accuracy being off. One example would be, in your balance, you weigh it out, it says 0.0. So if your balance, before you weigh it out, gets to that 0, and then you put the container on top to weigh out your chemicals, if you hit the 0 first, this boat weighs a certain amount. So you're adding that weight in. That's extra. That's not included. So if you add that in and then put something on top afterwards, what's going to happen is you're going to have the weight of the substance plus the weight of the weigh boat. So that weight of that weigh boat plus the substance is what you'd be registering instead, and that would have your answer or your information be off. So you would not have accuracy that you were looking for instead. Well, that lines up 2.4. We'll be using that in class in our measurements coming up.